What's up everyone? Welcome back to my channel. Today we'll be going over the exercise of modeling threads by hand. By the end of this video, the model that we have created should be 3D printable and should work with existing metal hardware. Specifically in this video, we will not be focusing on the math and formulas associated with creating these threads. Instead, however, we'll be primarily focused on using Plasticity's native tools to model these precise threads. So what that means is, if you're someone who prefers math and formulas, there is another great video under the channel Learn Everything by Design, where the person goes over using the formulas you would find on Wikipedia to model these threads. I'll leave a link to their video in the description. Now to begin, we need to find a drawing to reference that shows us how to create these threads properly. The best drawing that I found is still from Wikipedia, which I'll have up right now. If this is your first time seeing something like this, feel free to pause and attempt to digest this drawing because there's a lot in here. But what I'm going to do right now is I'm going to jump into Plasticity to show you the same thing. Now in Plasticity, they've introduced the section analysis that's available in the top right corner. And what we'll do is we will look at the cross section of this nut and bolt that I modeled in order to reproduce what's on the diagram. In base selection tool, I'm going to select this flat surface on this nut. And then I'm going to activate section analysis by clicking on this top over here. And with this gizmo, I can drag down and start seeing the cross section. Now, if you look at the cross section, this corresponds to the drawing on Wikipedia. So when it says internal threads, really how I think about it now is that I think of a nut with the threads inside it. And for external threads, I think of the bolt and the threads on the outside. And then everything else is really just referencing the threads, right? So you can see P, that's the pitch. So like that's the peak to peak or the valley to valley distance. And then you have H, which is this height of this triangle. So if you had trouble understanding the drawing, now you can picture a nut and a bolt and the cross section. And that's what this drawing represents. There's three pieces of information for modeling precise threads. The first is the major diameter, which is the diameter of the bolt that we're trying to model. In our example, we're going to be modeling an M6 bolt. So the major diameter will be 6 millimeters. The second thing will be the pitch. I'm going to throw on a table that you can find on Wikipedia. If you look at this table, and I'll include links to both the metric and imperial, but for this example, we are modeling an M6 bolt. So if we look at this table, we find the nominal diameter of 6. And under the coarse column, you can see that our pitch is 1 millimeter. Our last piece of information that we need is H. We'll find H while we're modeling. First, I'm going to clear the cube on the screen. I'm going to go to one of the side views. So here I'm on the left view. And the first thing I'm going to draw out is our pitch. So using the line tool or Shift A, I'm going to draw a line and then press Tab and enter in 1, and it'll be 1 millimeter long. I want to center this on the origin. So with the line selected, I'm going to press G to move, F for freestyle, and then right click twice to center it on the origin. Now I'm going to press / to zoom in. So this is 1 millimeter long. The next thing we need to do is to model the triangle. I'm going to draw a line, redraw a line, press tab, and then enter in 60. And I'll make sure this line crosses the y-axis. So once I confirm it, with the selected, I can press Alt-X to mirror it across the x-axis to get the line on the other side. And that's our triangle. So with our triangle form, now we can find H. And H, as per the diagram, is exactly just the height of this triangle. So we don't need to know exactly what H is. We just know that after we've modeled this triangle, we can find H. So now I'm going to draw this line representing the height of the triangle. And I'm going to press G to move and move it to the side. And what I'll do now is I'll also press Shift D with this line selected to make a copy. Why do I need 2 copies of this line? Well, it's because in order to get the offset from the top and the offset from the bottom from our triangle, these measurements are derived from H. So from the top of the triangle, it is H over 8. And from the bottom, it's H over 4, a quarter of H. So using these 2 lines, I'm going to calculate exactly H over 8 and H over 4 using the built-in scale tool in Plasticity. In edge selection mode, I'm going to select one of these lines. I'm going to press S for scale. I'm going to press V for pivot. And I'm going to work from at the top first. So I'm going to set the pivot at the top of this line. Now I'm going to press S for uniform. And then now I'm just going to enter on my keyboard 1/8. This resulting line is exactly 1/8 of H. So now if I just draw a line across like so, that is the part of the triangle that we need to trim off. Press T for the trim tool. I'm going to now trim away that top of that triangle. Go back to edge selection. I'm going to select the second line and we're going to do the same exercise. With this line selected, I'm going to press S for scale, V for pivot, set this at the bottom of the line. Press S for uniform and then enter in 0.25. And likewise, I'm just going to draw a line that connects to the top of this quarter H line. That's how much we need to trim off of the triangle. So T for trim again. I'm just going to trim all of this. And now we have our thread profile. So you can see from the drawing that the diameter starts from the top over here. So using the line tool, I'm just going to draw from the middle of this threaded profile. Make sure it's drawing downwards vertically. And I'm going to press tab and then enter in, and we want the radius, not the diameter. So we just take the diameter and divide that by 2. So 6 divided by 2, our radius is 3. So I'm going to enter in 3. Using the center circle tool, we're going to draw that cylinder now for the bolt. So using the center circle tool, you can find it on the left-hand side over here. I'm going to press in the center. I'm going to press V to flip it to vertical, and I'm going to connect it to the bottom of this threaded profile. Now, the only thing left to do is really just to create a cylinder and then spiral this threaded profile around it. So we just have to determine what length of bolt we need. So for me, I'm just going to create a 10mm bolt. So I'm going to select this circle, D for distance, enter in 10. I'm going to press negative to move it this way. And that's my 10mm bolt. Now, we need to spiral this threaded profile around the cylinder. So in order to do that, there is a tool in Plasticity called the spiral, which we'll use. So I'm going to click on the spiral tool, select the center of the cylinder, make sure that we're drawing this spiral along the center of the cylinder. Drag it out like so. The exact size, it doesn't matter because we'll define it once we left click. This pop-up pops up right here. Now the length that we need is basically the length of the bolt that we're doing, so which we said is 10mm. For turns, this is the only formula that we're going to be using to calculate the number of turns we need. And that formula is going to be the length that we want divided by our pitch. So the length of the bolt is 10mm. Our pitch, as we identified before, is 1. So 10 divided by 1 is 10. So we need 10 turns. Now for the radius, we know our major diameter is 6mm. We divide that by 2. Our radius is 3. In phase selection, I just need to select this profile. I'm going to press on the 3 dots over here, look for sweep, and then I'm going to click on the spiral, and now we have our threads. And really, just modeling threads in Plasticity is as simple as that. So if we were to model a bolt, what I might do is I might extend this face a little bit, add a little bit of a chamfer, so as to make sure that it can insert into the bolts correctly. We haven't added any tolerances to these threads. For me, the only thing I need to do for my printer, and again, it might be different for different printers, but my printer, I think the tolerances are pretty good. So the only thing I needed to do to get it to work is to take this face over here, push this face down a little bit to give it a little bit more of a space so that it doesn't rub up right against the internal threads. So I'm just going to press D for distance. I'm going to enter in 0.1, and this is going on the wrong direction. So I'm going to press negative. For my printers, this is good enough. If it still doesn't work for you, you might want to make these threads a little bit thinner. So what you might want to do is take these faces now, these outer faces. I'm going to press D for distance, and I'm going to do the same thing. I'm going to do 0.1. Actually, I don't even need 0.1, 0.05. And that'll make these threads a little bit thinner. One last trick before moving on to, I guess, the nut. You can ask yourself whether or not you actually need a cylindrical profile, because what you can do instead is, if I Boolean this together, in order to make it stronger, because right now, if you were to print it, you would have to print outwards, and these threads will be go along the layer lines, which is a little bit weak. So ideally, you want to print it flat like this, but of course, it's hard to print these without supports. But if you don't need a cylindrical profile, what you could do is like you could just take a line and you kind of like cut off part of it, and this would still work, right? So I'm just drawing a line, selecting the line, press C for cut. I'm gonna cut into this profile. I'm just gonna delete this bottom half, and now you can print this face down, and this would still work if you don't need a cylinder. If you want to model a nut or something with internal threads, I'm just going to quickly do that now by selecting the polygon tool, and I'm going to shift and then wheel down to make it a six-sided polygon or hexagon. I'm going to extrude it a little bit. I don't know, some depth over here. And I'm going to use the center circle tool, and I'm going to make sure that I create a circle that is not entirely 6 millimeters because I need some material. What we're going to be doing is we're going to be using this bolt that we modeled to cut threads into this nut. Instead of 6, I might enter something like 5. And I'm going to now press C for cut. I'm going to cut into the cylinder, delete that cutout section in the middle. And why I want to cut it out is, similar to how we added a chamfer to this bolt, you might want to add a chamfer to the opening of the nut. So I'm going to select these two over here, press C for chamfer. And I'm just going to add a little bit of a chamfer, and you can be as precise as you want. And then the next thing you want to do is I'm just going to take this bolt. I'm just going to G to move it along the Y direction so that it's inside of the nut. And now I can first select the nut, press Q, and then select the bolt. I'm going to press T because I want to keep the bolt, and then right click to confirm. If we just look at the section analysis of this over here and we zoom in, there are no tolerances, right? We cut it precisely. So I'm going to hide this bolt so we can see the inside of the internal threads. And similar to how we kind of push down the internal threads, here we can push this face further to make room for the threads as well. And then also widen the distance over here between these two faces to give it a little bit more space. I'm going to select this face over here and press D, enter in 0.1. Against going in the wrong direction, I'll put negative, and then enter twice to confirm. And then similarly, I'm going to select these two faces, D, 0.1, negative, and then now we've kind of widened everything up. So if we now show the bolt again, now we've added some space to allow the bolt through. And yep, that's pretty much it. That's the tutorial. Hopefully this helps. There are better tools out there to model threads, but if you really wanted to do it in Plasticity, hope that you found that this method works for you. Thanks for watching. Have a good one. See you next time.